Welcome back. We are, still in Unit 4 on our ACT prep, intermediate algebra topics, and today we're going to talk about solving quadratic inequalities. Alright, so quadratic inequalities. We can do factoring, or we could use the quadratic formula to solve quadratic inequalities. You use the same technique. It's just that instead of having an equal sign, you're going to have one of these symbols, less than, greater than, less than or equal to, greater than or equal to. You got to consider the following cases. So you're going to need this says if the quadratic inequality is written less than 0, then the two factors have different signs. That's not really very helpful. What you do is you look at a number line and you see where these symbols are true. So it says solve this. Okay, well, first of all, you can either factor or you could do quadratic formula. This is difference of squares, so I'm going to factor bino, plus and minus, square root is x and 3. And then I'm just going to set it equal to 0 for right now. So if I solve this, I have x plus 3 equals 0, x minus 3 equals 0, so x equals negative 3, and x equals positive 3. Now, what you do is you look at a number line. So I'm going to put my 3 on the number line, and I'm going to put my negative 3 on the number line. Okay? And then you test. You pick something smaller. So I'm going to pick negative 4. And you plug it in. You can either plug it in here, or you can plug it in here. I like to plug it into the factors because, watch. Got negative 4 plus 3 times negative 4 minus 3. And I want to know, is that less than 0? Well, I don't really care what the numbers are. You just need the signs. Okay, negative 4 plus 3 is going to be a negative. Negative 4 minus 3 is going to be a negative. A negative times a negative is a positive, which is never less than 0. So this is false. So your answers are not in that section. No. Okay, then test in between them. 0 is wherever I can pick 0 to try, I pick 0. So I plug that in. I have 0 plus 3 times 0 minus 3, and I want to know, is that less than 0? Oh, by the way, there's no bar under there, so these are going to have open circles. Okay, those are my solutions, but I can't include them because it doesn't say or equal to. Anyway, this is going to be a positive. This is going to be a negative. A positive times a negative is a negative, which is always less than 0, so this section is true, which means everything in between those solutions are solutions. Okay, and then if I test the outside, or above 3, pick something like 4, okay, plug that in, I would have 4 plus 3, 4 minus 3, is that less than 0? Well, this will be a positive. This would be a positive. A positive times a positive is a positive, which is never less than 0, so this section is false. So my solutions are everything between negative 3 and 3. And the way you write that, we've talked about this before, is you say my solutions are between, not included, so no bars, negative 3 and 3. Okay? Now, that's a lot of work. If you use a graphing calculator, you can tell a lot faster. Okay, so if I type this in, x squared minus 9, and I put 0 on the second one, all right, and I hit graph, I can get my intersections. There's one at 3, there's one at negative 3, so there's my boundaries. And then all you do is look. They want to know, when is the parabola, this is a parabola, when is the parabola below 0? Well, here's 0. Anything it's below right here, yeah? Well, what section of x does that cover? That goes from this point to this point. These x coordinates give these y values, which are the part of the parabola that's below the 0. So, again, you can tell from the picture that I have to color between, and there is my and statement. Okay? And pretty much, well, no, I ain't going to go there. All right, so if I look at this one, it's the same problem, but now they want greater than 0. Well, I'm not going to do the problem again. We know that we got x equals 3 and x equals negative 3. And we know negative 3, 3. excuse me, when I pick it this time, so when I pick negative 4, I guess I need my factors, x plus 3 times x minus 3 greater than 0. And I plug in negative 4, I'm going to have negative 4 plus 3, negative 4 minus 3, and I want to know now, is it greater than 0? Well, this is going to be a negative. This is going to be a negative. A negative times a negative is positive, which is always greater than 0. So now this section is true. But when I check the middle, pick 0, 0 plus 3, 0 minus 3, is that greater than 0? Well, this is going to be a positive. This is going to be a negative. A positive times a negative is a negative, which is never greater than 0. So now this section is false. And when I pick something above 3, like 4, I get 4 plus 3, 4 minus 3. Is that greater than 0? Well, that's a positive. That's a positive. A positive times a positive is a positive, which is always greater than 0. So this section is true. So now, again, I still can't include the 3's, but my solutions now lie outside of the 3's. And the way you write that is x is less than negative 3, or x is greater than positive 3. And again, if you look at the graph, okay, now I'm looking for when is the parabola above 0. Well, that's this part and this part. Well, to get these points, to get those y-coordinates, we have to use these x-coordinates. This x-coordinate would get that point way up there. This would get that point. This would get this point. This would get this point, this point. And to get these ordered pairs, you'd have to use these x's, but you can't include those. So you can see from the picture, to get the part of the parabola above, I use these x-coordinates and these x-coordinates. So again, x is less than negative 3, or x is greater than positive 3. Okay? Alright, try this one. Hit pause. Well, I guess you can look at it, it ain't gonna hurt. Hit pause, come back when you're ready. And hopefully you got C. Okay, so if I factor, should be an easy factor because A is 1. X and X. Factors of 8 that make 2 would be 2 and 4. C is negative, which means my signs have to be different. So bully gets, they both want the middle, but when C is negative, only one can be the middle. So 4 is going to be the plus, 2 is going to be the minus. If I solve that, x minus 2 equals 0, x plus 4 equals 0, I get x equals 2, and x equals negative 4. Stick those boys on a number line. You got negative 4, you got positive 2. Test, pick something down here. I'm going to pick negative 5. So I would have negative 5 minus 2, negative 5 plus 4, and we're seeing, is that greater than or equal to 0? That's going to be a negative. That's going to be a negative. A negative times a negative is a positive, which is greater than or equal to 0. So this section is true. Pick something in the middle, like 0. Plug that in. I would have 0 minus 2, 0 plus 4, greater than or equal to 0. That's a negative. That's a positive, which is negative, which is never greater than 0. So this section is false. And check the upper. Plug in something like 3. So 3 minus 2, 3 plus 4. See if that's greater than 0. Well, that's going to be a positive, and that's going to be a positive. A positive times a positive is a positive, which is always greater than 0. So this section is true, which means I can color there. Now, you see how it's got the bar? That means my solution ends are included. So again, we have an OR statement, and this says that x is less than or equal to negative 4, or x is greater than or equal to 2. Okay? Again, looking at the picture, we want to know when is the parabola above 0. Well, that's here and here, which corresponds to these x-coordinates and these x-coordinates. So it's an OR statement. Alright, so if we practice these, alright, if I factor this, I get x plus bino, plus n, mino, which means my solutions are negative 4 and positive 4. So if I draw a number line, and I put that on there, -4, +4, and I test, take something smaller than -4, preferably not in blue. Let's pick, I don't know, -5. So if I plug that in, I'm going to have -5 plus 4, -5 minus 4, and I want to know, is that less than 0? Well, that's going to be a negative, and that's going to be a negative. A negative times a negative is a positive, which is not less than 0, so this section is false. Check the middle section. 0 is always nice. So 0 plus 4, 0 minus 4, is that smaller than 0? Well, that's going to be a positive. A negative, which is less than 0, so it's true there. Open circles because there's no bar. Check the upper end. Plug in 5. I'm going to have 5 plus 4, 5 minus 4. Is that less than 0? Well, that's going to be a positive, and that's a positive, which is a positive, which is never less than 0, so that section is false. So it is true when it's between, which means my x is less in between -4 and 4. And again, if you plot it on a graph, they want to know, when is the parabola below 0? Well, it's right here, which corresponds to these x coordinates, which is between the two solutions. Okay. All right, number 2, if I factor, the only thing the two terms, and they're not squares or cubes, so I can GCF an x out, which would leave x plus 7. I'm going to use equal right now. So I got x equals 0 and x plus 7 equals 0, which means x equals -7. So on my number line, -7, 0. And we test. I'm going to test something down here like -10. So I'd have a -10 times -10 plus 7, and I want to know, is that less than or 0? Less than or equal to 0. Well, that's a negative, which is a positive, which is not less than or equal to 0, so this is false. Check something in between. How about -1? That would give me -1 times -1 plus 7, and I want to know, is that less than or equal to 0? Well, that's a negative. That's a positive, which will be negative, which is less than or equal to 0, so this is true. And I include them because of the bar. Any guesses on what's going to happen above? Alright, pick one, anything actually. So 1 times 1 plus 7, is that less than 0? This is a positive, this is a positive, which is a positive, which is never less than 0, so this section is false, which means my x's are between and include -7 and 0. And if you look at the graph, okay, typed it in, they want to know, when is it below 0, which is here, which corresponds to the x's in the middle. Okay. Alright, so let's do a couple more. We've got difference of squares again, so bino, plus and mino. Square root of x squared is x, square root of 25 is 5. So my solutions are -5 and 5 on a number line. And we test. Pick something below, like -6, and plug it in. That would be -6 plus 5, -6 minus 5, and I want to know, is that greater than 0? This is a negative, and that's a negative, which makes a positive, which is greater than 0, so this is true. I can include it, so open circle, but color this way. Pick something in between. How about 0? That'll give me 0 plus 5, 0 minus 5, greater than 0. That's a positive. That's a negative, which is never greater than 0, so that section is false. Pick something up above, like 6. 6 plus 5, 6 minus 5, is it greater than 0? Well, that's a positive, which is never greater than 0. Oh, which is always greater than 0, sorry. so that section is true. So open circle, and I can color there. Okay, so my solutions point outwards, which means to write my solution, I say that x is less than -6, or x is greater than, not -6, -5, or x is greater than 5. Be careful. What I just see, you test these numbers and you start to think the ones you tested are your solutions. No. Be careful, careful, careful. And again, if you look at the picture, I want to know when is the parabola above, that's here and here, which correspond to those x's and those x's. All right? Number 4 is another GCF one. Two terms are not perfect, so I can GCF an x out, which would leave x minus 4, which gives me x equals 0 and x minus 4 equals 0, which means x equals 4. So if I graph that, I've got 0 and 4, and I test. Pick something down here, like, I don't know, -2. I have -2, -2 minus 4, and I want to know, is that greater than or equal to 0? Well, that's a negative, and that's a negative, which is a positive, which, yes, is greater than 0. So this is true, and I can include it. And have you guys figured out something yet? I mean, some weird things can happen. It's not necessarily smart to trust this. Weird things can happen, but usually, and again, in an ACT type situation, to do all these tests take time. This is a little faster. The calculator is a little faster, yes, except for even if you do it on the calculator, you still have to go through, calculate the zeros, left bound, right bound, yada yada yada. I don't know if it's more time consuming by hand or by calculator, honestly. But have you noticed that our answers are kind of always alternating? See how it goes true, false, true? Let me back up. False, true, false, false, true, false. What was this? True, false, true. You see how they're always alternating? And pretty much they're going to do that. Okay, like I said, some weird things can happen, but generally speaking, once you find one section, whether it's true or false, you pretty much can alternate for the other sections. It might bite you, because there are some weird things that can happen, but again, I ain't going to shortcut it on this, but if I was actually taking an ACT, I'd probably shortcut it and just assume once I found one section what the others are going to be. All right, so this is not in quadratic form, so I'm going to -8 minus 8, and that gives me 3x squared plus 10x minus 8 equals 0, or less than or equal to 0. Okay, and to factor this, I'm going to have to do 8 times c, so 3 times 8 is 24. Factors of 24 are 1 and 24, which won't make 10. 2 and 12 will, so will 6 and 4. Remember, that's very rare for you to be able to make B two different ways, but when you can, only one's going to work, and C will tell you. I need the pair that is subtracting to make 10, which means I need the 2 and the 12. So I'm going to rewrite B with 2x and 12x. Signs, C is negative, which says they have to be opposite then. And Bully gets the middle. So he takes the plus, 2 takes the negative. Drop your ends. 3x squared on the front, minus 8 on the back. And we are now at 2 by 2. I can GCF an x out, which would leave 3x minus 2. On the other side, I can GCF a positive 4, divide, and I get 3x minus 2. At this point, you better have matching binos or you did something wrong, but I do, so I didn't, which means my final GCF is 3x minus 2, divide, and my second factor is x plus 4, less than or equal to 0. So if I solve these, I got 3x minus 2 equals 0, add 2, 3x equals 2, divide by 3, x equals 2/3. Don't panic on fractions. We're not testing the actual fraction. Okay, and then to get my other one, this is x plus 4 equals 0, so x equals -4. Alright, and there's a bar, so we get to include our solutions. We just got to figure out, is it between or outside? Well, let's test. Alright, if I test something down here, like -5, I'd have 3 times -5, which is -15 minus 2, and -5 plus 4. This is going to be a negative, this is going to be a negative, which is a positive, which is not less than or equal to 0, so that is false. And what I was saying before, pretty much, if, again, I'm not going to do it now, but if that's false, then this is going to be true, and this is going to be false. Should be, unless something weird happens. Alright, but let's test anyway, just to check. 0 is always nice to check, so we would have 3 times 0 is 0 minus 2, and 0 plus 4, that's a negative, that's a positive, which is negative, which is always less than or equal to 0, so it's true here, just like I thought. Pick something bigger than 2/3. Well, 2/3 is 0.6 something, so I'm just going to pick, I don't know, 2. 3 times 2 is 6 minus 2, and 2 plus 4. That's going to be a positive, that's a positive, which is a positive, which is never less than 0. So like I said, that section is false. Whoa. My solution is in between -4 and 2/3. So I say x, and including -4 and 2/3. And if you look at the graph, okay, this one's kind of weird. I typed it the way they did. So I put 3x squared plus 10x on y1 and 8 on the other. And I want to know, when is the parabola part smaller than the line part? Well, here's your x equal 8 line. And I want to know, when is the parabola below it? Well, that's here and here, which correspond to those x's. Okay? Number 6, that's difference of squares, so bino, plus and minus, 2x plus 3, 2x minus 3. Alright, to get my solutions, I set them to 0, 2x plus 3 equals 0, minus 3, 2x equals -3, divide, and x equals -3/2. Same thing over here, just different signs. That's 2x equals 3, divide by 2, x equals +3/2. So, I have -1.5 and +1.5, if the fraction bothers you. Alright, so now let's test. Like I said, -3/2 is -1.5, so I think I'll pick -2. If I plug those in, 2 times -2 would be -4 plus 3. 2 times -2 would be -4 minus 3. That's going to be a negative. That's going to be a negative, which is a positive, which is always greater than 0. So this is true. And I'm including. And if I was betting money, then I would bet this is also going to be true, because my true-false are going to alternate. But let's check it. If I check the middle, 0's in between there. 2 times 0 is 0 plus 3. 2 times 0 is 0 minus 3. That's a positive. That's a negative. That's a negative, which is never greater than 0. So, like we said, this is false. Pick something higher than 1.5, like 2. That would be 2 times 2 is 4 plus 3. 2 times 2 is 4 minus 3. Well, that's a positive, and that's a positive, which is a positive, which is always greater than 0. So this is true. Which means my solutions are all x's less than -3/2, or all x's greater than or equal to 3/2. And again, if you look, this one's saying, when is the parabola above 0? Well, that's here and here, which correspond to those x's and those x's. Okay? All right, number 7. If I factor, I got 2 times 5 is 10. Factors of 10 that make 11 would be 1 and 10. So rewrite B as 1x and 10x. Signs, C is positive, which means the signs have to be the same, and they'll be the same as the middle, so they're both negative. bring down the first and the last. So 2x squared on the front, 5 at the back, 2 by 2. Getting faster at this now, aren't you? Alright, I can GCF an x. Divide leaves 2x minus 1. On this side, I can GCF, I'm going to use a negative because the first guy's negative. 5 goes into both. Divide, and I get 2x minus 1. Again, at this point, you better have matching binos or you screwed up, or it's prime. I do have matching binos. My GCF again is 2x minus 1, which leaves x minus 5. Okay, set them to 0 and solve. 2x minus 1 equals 0. Add 1. 2x equals 1. Divide by 2. X equals 1/2. X minus 5 equals 0. Add 5 and you get x equals 5. So on my handy dandy number line, I got 1/2 and 5. Test. Pick something less than 1/2, like 0. So I'd have 2 times 0, which is 0 minus 1, and 0 minus 5. And then I'm looking to see if that's greater than or equal to 0. Well, that's going to be a negative, and that's going to be a negative. And a negative times a negative is a positive, which is always greater than 0. So this is true. Pick something in the middle between 1/2 and 5, like, I don't know, 1. So I'd have 2 times 1 is 2 minus 1, 2 times, and 2 minus 5. Well, that would be a positive, and that would be a negative, which is a negative, which is never greater than or equal to 0. So this section is false, just like I thought. And try the upper one. Pick something bigger, like 6. 2 times 6 would be 12 minus 1. 6 minus 5, that's a positive. That's a positive, which is a positive, which is never, or which is always greater than or equal to 0. So that's true. And I can include that. No, oh, there is a bar, so I include the ends. And so my solution says x is less than or equal to 1/2, or x is greater than or equal to 5. Okay? And if you look at the picture, I want to know, when is the parabola above? Well, that's here and here, which corresponds to those x's and those x's. All right, number 8, I'm not in quadratic form. So I'm going to minus 8x, and minus 20, minus 20. That gives me 0, and I get x squared minus 8x minus 20. I'm going to factor, should be an easy factor, a is 1. X and x, factors of 20 that make 8 would be 2 and 10. C is negative, so my signs have to be opposite, and bully takes the middle. So 10 takes the negative in the middle, which means 2 is plus, which means my boundaries, my solutions are negative 2 and positive 10. Negative 2, positive 10, and we test. And as I get even lazier and lazier, I always pick the 0 to test first. So wherever that is, I test 0 plus 2, oops, 0 plus 2, 0 minus 10. That's going to be a positive, a negative, which is negative. And they want to know greater, oops, is that greater than or equal to 0? No, just greater than, which it's not. So this is false, which means the ends are going to be true, right? Sorry, I don't know why that keeps popping up right now. So let's check an end. How about negative 3? So I'd have negative 3 plus 2, negative 3 minus 10. That's going to be a negative and a negative, which is a positive, which is always greater than 0. So this is true, but not included. And test something over here, like maybe 11. So I'd have 11 plus 2 times 11 minus 10. That's a positive and a positive, make a positive, which is always greater than 0. So this section is true, but don't include it. Which says x is less than negative 2, or x is greater than 10. All right, and if you look at the picture, they want to know when is the parabola above this slanted line. Well, here's your slanted line. It's above it here and here, which correspond to here, which correspond to these x's and these x's. Okay? Oh, and then this is the one where I did it, where I got 0 on one side. All right, number 9. We got to get it in quadratic form, so minus 12x minus 12x. That's going to give me x squared minus 12x plus 27 less than 0. Should be an easy factor. A is 1. 9 and 3 make 12. C is positive, so they both have to have the middle sign, which means x equals 9 and x equals 3 on a number line. And I start testing. If I test negative 4, that'd be negative 4 minus 9, negative 4 minus 3. That's a negative times a negative is a positive, which is never less than 0. So this section is false. Pick something in the middle, like, I don't know, 5. Test it. 5 minus 9, 5 minus 3. That's a negative. That's a positive, which is negative, which is less than 0. So this section is true, but I can't include the ends. And then test something higher than 9, like 10. I'd have 10 minus 9, 10 minus 3. That's a positive, which is a positive, which is never less than 0. So this section is false, which means my solution is between 3 and 9. Again, on the picture, if you see it, you're trying to figure out when the parabola is actually below the line, which would be here, which would go from this x to this x, which is like 3 to 9. Okay, on 10, we're not in quadratic form, so I'm going to have to minus 15, which gives me x squared plus 2x minus 15 less than 0. Again, should be an easy factor, x and x. 5 and 3 make 2. C is negative, which means they have to have opposite signs, and bully 5 will take the middle sign, and he won't. That gives me solutions of negative 5 and positive 3 on my number line. And now we test. So if I test something down here like negative 6, I'd have negative 6 plus 5, negative 6 minus 3. That's going to be a negative times a negative, which is a positive, which is not less than 0. So this is false, which means probably the middle is true, but let's check it out. 0 is easy pick. I have 0 plus 5, 0 minus 3. That's going to be a positive, a negative, which is less than 0. So that's true, but don't include the ends. And the other end, I'm sure, is going to be false, but let's check. If I pick 4, 4 plus 5, 4 minus 3, that's a positive times a positive, which is never less than 0. So that would be false. So my solutions are between negative 5 and 3. And if you look at the calculator, I want to know when is this parabola below the 15 line. There's my 15 line. It's below there, which corresponds to those x's in the middle. Okay? All right, number 11. I got to get it in quadratic form, so I'm going to minus 8. Minus 8, that gives me x squared minus 16 greater than 0. Factor x plus 4 times x minus 4, which gives me solutions at negative 4 and 4 on my number line. And we start testing. Pick something smaller than negative 4, like negative 6. So I'd have negative 6 plus 4, negative 6 minus 4. That's a negative. That's a negative. A negative times a negative is a positive, and that's greater than 0, so this is true. And I color without a bar. So keep it open. Okay, test the middle. 0 is a good one. 0 plus 4, 0 minus 4. That's a positive. That's a negative. A negative is not greater than 0, so this section is false. Pick something bigger than 4, like 6. And I have 6 plus 4 and 6 minus 4. That's a positive. That's a positive, which is greater than 0 always. So this is true, but not included. So my solution is x is less than negative 4, or x is greater than positive 4. See how I wrote the 6 again? Okay, 12, we're in quadratic form. So if I factor, 2 times 3 is 6. Factors of 6 that make 1 would be 2x and 3x. C is negative, so signs have to be different. 3x copies the middle. Bully gets the middle, and he don't. Drop your first and your last. So I got 2x squared here, minus 3 here. And we are now at 2 by 2. I can GCF a 2x, which would leave x plus 1. On the other side, I can GCF a negative 3, which gives me positive x, positive 1. And like I said, we better have a common binom or we're in trouble, but we do. So my GCF again is x plus 1, which after I divide by that, leaves 2x minus 3. That gives me x equals negative 1 and x equals 3 halves. So on my number line, negative 1, 3 halves, we test. Pick something like negative, 5. So negative 5 plus 1 times 2 times negative 5 would be negative 10 minus 3. That's going to be a negative. That's going to be a negative, which makes a positive, which is greater than 0. So this section is true. Open circle. Okay? Alright, then we test the middle. 0. So I have 0 plus 1. 2 times 0 would be 0 minus 3. That's a positive. That's a negative, which is a negative, which is never greater than 0. So this section is false. And my upper section, if I test it, I'll pick 3 halves is 1.5, so I'll pick 2. So I'd have 2 plus 1 times 2 times 2 is 4 minus 3. That's a positive. That's a positive, which is always greater than 0. So this section is true with an open circle. So again, I would say that x is less than negative 1 or x is greater than 3 halves. Alright, and if you look at the graphs, we wanted to know when is the parabola bigger than the line. Well, there's your 8 line. It's here and here, which corresponds to those x coordinates. Okay? On this one, they wanted the parabola that was above 0. Well, again, that's here and here, which means they want those x coordinates. Alright. We got to get in quadratic form, so minus 2x, x squared minus 2x plus 1 equals 0. Should be an easy factor. Factors of 1 that make 2. C is happy, so they both get the middle, which means I have a double root at x equals 1 and x equals 1. So if I look at 1, and it's not or equal to, and with one solution, that's less tests. So if I test something over here like negative 2, that'd be negative 2 minus 1, negative 2 minus 1, and I want to know, is that less than 0? Well, this is going to be a negative, and this is going to be a negative, which makes a positive, which means it's never less than 0. So this section is false. Pick something above, like 2. 2 minus 1, 2 minus 1. This is going to be a positive. This is going to be a positive, which is a positive, which is always greater than 0. So this section is true. And again, I bet you can bet what's going to happen up on the next one. Let's plug in 4. So I have 4 minus 1, 4 minus 1, which is a positive, times a positive, which is a positive, which can never be less than 0. So that section is false. No bar means don't include them, so my solution is x is between negative 2 and 2. 14, 2 terms. All I can do is GCF, but I can GCF a 3 out, which would leave x squared minus 4 less than or equal to 0. This is difference of squares, which is going to factor bino, plus and mino. Square root of x squared is x. Square root of 4 is 2, less than or equal to 0. So I have 3 factors, but it's kind of silly because this one doesn't, I mean, I can set it to 0, but it doesn't have an x in it. There's nothing to solve for. It's just a multiplier. Okay, so I got x plus 2 equals 0, x minus 2 equals 0, so x equals negative 2, and x equals 2 on my number line. And we test. So if I pick something over here like negative 3, that'd be 3 times negative 3 plus 2, negative 3 minus 2. Well, 3 is obviously positive. That's going to be a negative, and that's going to be a negative, which is going to be positive. So that's never less than or equal to 0, so this is false. And I am going to run out of time before this bell starts and all my kids come in and you guys can't hear me. So I am going to cheat now and start just alternating. If this is false, it's going to mean this is true. And this, again, might bite me in the butt, but save some time. So this would be my x's are between, but not, and include, close circles, and include negative 2 to 2. All right? Oh, and if you look at this one, also, what was the answer? Oh, never mind. What did I do? Oh my goodness, I'm getting sleepy. Guys, I don't know what I did right here, but where did I get 2 and negative 2 from? I think I'm falling asleep here. Sorry. My answer, there's only one solution. It's at, I got a double root. It's at 1. All right, and I can't include it because there's no bar. So if I test each side, maybe that's what I was trying to do. I apologize. So if I test positive 2, I get 2 minus 1, 2 minus 1. That's a positive times a positive, which is never less than 0. So this is false. If I try something on the other side, like 0, I get 0 minus 1, 0 minus 1. That's a negative times a negative, which is a positive, which is never less than 0. So this is false. And I can't include the one solution that works, so if I can't include anything, this thing has no solution. And if you look at the graph, it does touch right there, okay? But because of the no bar, that's not even included. All right, and on this one, there's my between the twos. I don't know what I was doing there. But anyway, we want to know when is the parabola below 0? Well, that's here and here, which corresponds to the x's in the middle. All right, on 15, I got to get it in quadratic form. So I'm going to minus 6x, and add 5, and add 5. And I get x squared minus 6x plus 5 less than or equal to 0. Should be an easy factor. A is 1, so x and x. 1 and 5 make 6. 5, C is positive, so they both copy the middle. which gives me solutions at x equals 1 and x equals 5. On my number line, 1, 5, I'm going to test one area. So I'm going to test 0. So if I test 0 minus 1, 0 minus 5, and see, is that less than or equal to 0? Well, this is going to be a negative, and this is going to be a negative, which is a positive, which is never less than 0. So this section is false, which means, again, I'm gonna skip some steps now, even though I told you I wouldn't. I'm going to assume, okay, that this would be true and that this would be false, which means my solutions are between and include because of the bar. So my answers are between and include 1 and 5. Check the graph. Okay, I want to know when is the parabola below the line, which is here to here, which is this x to this x. Okay. Number 16, all I can do, it looks like, is GCF. I can take a 16 out, which leaves x squared minus 2 less than 0. Set them to 0. 16 can never equal 0. That's just a multiplier. X squared minus 2 equals 0. To solve it, I would add 2, x squared equals 2, square root, x equals plus or minus the square root of 2. I mean, if you want to know, it's approximately 1.4 something, and negative square root of 2 would be negative 1.4 something. Alright, so when we test, again, I'm just going to test one section. I'm going to test the center, because 0 is easy to test. And if I plug that in back to the original, I'd have 16 times 0 squared minus 32 less than 0. Is that true? Yes, a negative is. So it's between, but not included. So x is between a negative square root of 2 and a positive square root of 2. And if I graph, okay, I'm looking for the parabola below 0, that's here to here, which corresponds to the middle x's. Alright, on 17, this one's kind of funny. If you graph this, because this one's going to be upside down, okay? When you graph this, I want to know when is this upside down parabola smaller, because you got to read it from the x's side. When is this parabola smaller than 0? So again, I'm looking here and I'm looking here, which corresponds to well, if I test, see when this is negative, it jacks everything up. Because when you divide, oh, that's right, because when you divide by that negative, you're actually going to flip that inequality. So I'm actually looking for where it's above. Okay, which would be here, which is between negative 4 and positive 4. Okay, so my solution would be x is between, is there a bar? Negative 4 and positive 4. Alright, 18. I can GCF an x out, which would leave 4x plus 5 greater than or equal to 0. So I got x equals 0, and I got 4x plus 5 equals 0, minus 5, 4x equals negative 5, divide by 4, and I get 0 and negative 5/4. So there's negative 5/4, there's 0. I'm going to pick one section to test and then alternate because I'm running out of time. So if I pick 1, I would have 1 times 4 times 1 is 4. That's a positive times a positive, which is a positive, which is greater than 0. So this is true, which means the middle is false, which means this is true, which means x is less than or equal to negative 5/4, or x is greater than or equal to 0. And if we check the graph, okay, I want to know when is the parabola above, which is here and here, which correspond to the outer x's. All right, on 19, I've got to get in quadratic form, so add 4x, add 4x. I get x squared plus 9x less than or equal to 0. Now factor out an x, leaves x plus 9, which gives me solutions x equals 0 and x equal negative 9. On a number line, negative 9 and 0. Test a section. I'm going to test here, so pick, I don't know, 2. So I'd have 2 times 2 plus 9, that's a positive, times a positive is a positive, which is never less than 0. So if that's false, then this is true, and that's false. Bar means include, so my solutions are between negative 9 and 0. And if I check the graph, when is this parabola smaller than that line? Well, that would be from here to here, which corresponds to those x's. All right, on 20, if I just solve this thing instead of trying to factor it, divide by 1,000,000 on both sides, and you get x squared greater than or equal to 0. Square root that, and you get x equals plus or minus 0, which is silly. 0 doesn't have a sign. But what that means is your only solution is going to be at 0. So kind of like when we got that double 1, we got double zeros. So if I test each side as 0, if I test 5, and I plug it in, and I do, well, I'm going to plug it in here because it ain't going to matter there. If I plug it in here, is 5 squared greater than or equal to 0? Well, yeah, so that's true. Check something on this side. Well, if I pick negative 5 and square it, it's still positive 25, which is greater than or equal to 0. This is what I mean by sometimes weird things happen. So that's true. And even the 0 is true because of the bar means I can include it, which means I colored everything. So my solution is all real numbers. All right, and you can see that it hits right here and it wants to know when is that above. Well, it's always above, so it's all real numbers. All right, you try this one, hit pause, come back when you're ready. And hopefully you got B. All right, it should be an easy factor. X and X. Factors of 12, 2 and 6 make 8. C is positive, so they both have to match the middle, which gives me solutions at x equals 2 and x equals 6 on a number line. Pick a section to test. I'm going to test 0 because it's easy. So I have 0 minus 2, 0 minus 6. That's a negative, which is a positive, which is not less than 0. So this is false, which means this is true, and this is false. No bar, open circles. And that says that my solutions are between 2 and 6. Graph it. You can see they want to know when is the parabola below 0. Well, that's here to here, which corresponds to those x coordinates. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got F. All right, on this one, what you could do is you're trying to take this and go back to what the solutions were. Well, what this says is you got to do a couple things here. First of all, there's no bars, so my answers can't have any bars, so those are out. The other thing is if this was my problem and I did minus 3, I'd have x squared less than negative 3, and when I square root, that's not even real. So that's not possible. So it's now I just have to decide, is it this one or this one? So what I did was I looked at the graph, okay, and I want to know the one where basically this is my solution, is between those two. Well, if I graph them, when I graphed x squared minus 3, there is, okay, when it is between here, this doesn't even cross the x-axis, so it can't be the plus, it's got to be the minus. I mean, it can't be the greater, it's got to be the less. Okay? All right. try this one, hit pause, come back when you're ready. And hopefully you got D. So it should be an easy factor, x and x. Factors of 4 that make 3 would be 1 and 4. C is negative, so Bully gets the middle and he doesn't, which gives me solutions at positive 1 and negative 4. Pick a section and test it. I'm going to test 0. So 0 minus 1, 0 plus 4, that's a negative, that's a positive, that's a negative, which is not greater than 0. So this section is false, which means this section is true. And my solution is x is less than negative 4 or x is greater than 1. Alright, and you can see they want to know when is the parabola bigger than 0. Well, that's here and here, which corresponds to those x coordinates. Alright, try this one, hit pause, come back when you're ready. Sorry about the answers there. And hopefully you got H. I could GCF an x out, which leaves x minus 3 equals 0, which gives me x equals 0 and x equals 3. Put them on a number line. Pick a section and test it. I'm going to test 1. So I'd have 1 times 1 minus 3. That's a positive. That's a negative, which is less than or equal to 0. So this section is true, which puts me between 0 and 3. Alright, try this one, hit pause, come back when you're ready. Alright, and what I did was, oops. Hopefully you got E. What I did was, I looked, okay, my x has to be, it's got to be less than or equal to, for one thing. So A is out and D is out, okay? The other thing is, if I factor these, okay, this one is going to factor into x plus 8, and, oh, we already ruled that one out. This one would factor into x minus 3, x minus 8, which would not give me minus 5 in the middle, okay? That would give me, oh heck, what am I doing? 8 and 3 is 24. Yeah, but this says they would have to match, and that would not give me 5 in the middle. That would give me 11 in the middle. So B is out. So now all I have to do is figure out, these factor the same, but is it greater than or is it less than? Well, you have to look at which one is true. Okay, if I looked at C, and I did greater than, where's my graph? If I did C and I did greater than, okay, oh, I just graphed them. The 3 I wasn't sure of. And I want the one that's between, okay, which has to be that one. Alright. That ruled that one out. That ruled that one out. I put that one in, and the only way it's going to be between is if you go below, so that's why I want the less than or equal to. Alright? And that does it for day 6. So I will see you next time for day 7.